The Great Pyramid of Giza contains over 2 million stone blocks, weighing up to 80 tons each. Its base is level to within 2.1 centimeters across 230 meters. Its four corners align to true north within a fraction of a degree. This was not luck. It was mathematics. Egyptian geometry began with a practical problem. Every year, the Nile flooded and erased field boundaries. Every year, surveyors had to re-establish them precisely. The geometry they developed to do this eventually built the pyramids. The Rhind mathematical papyrus, written around 1650 BC, is one of the oldest mathematical documents in existence. It contains 84 problems covering fractions, areas, volumes, and slopes, a practical manual for Egyptian engineers and administrators. The Egyptians used a unit called the seek to measure pyramid slope, the horizontal distance for every cubit of vertical rise. This was sophisticated trigonometry by another name. Getting the seeked wrong meant a pyramid that wouldn't converge at its apex. The logistics behind pyramid construction were as extraordinary as the mathematics. Feeding, housing, and coordinating tens of thousands of workers required advanced planning, accounting, and supply chain management. The pyramid was an organizational achievement as much as an engineering one. Egyptian surveyors used a rope with 12 equally spaced knots to form a 3-4-5 right triangle, a perfect 90-degree corner every time. This technique, using what we now call the Pythagorean relationship, predates Pythagoras by over 1,000 years. Egyptian architects worked from detailed plans drawn on papyrus and limestone flakes. Measurements were precise, scales were used, and design decisions were made on paper before a single stone was moved. Ancient architectural drawings, functional and mathematically rigorous. The Great Pyramid's outer casing stones were fitted with joints of less than half a millimeter. No mortar. Just precision cutting and careful placement. Modern stonemasons working with power tools struggled to match this standard. Ancient Egyptians achieved it with copper tools. The Rhind papyrus contains a formula for the area of a circle that implies a value of pi as 3.16, remarkably close to the true value of 3.14159. Egyptian mathematicians were approximating one of mathematics' fundamental constants 2,000 years before the concept was formally named. Annual Nile flooding created the world's most demanding surveying challenge, and the world's most advanced geometry to meet it. The need to remeasure the same land repeatedly drove refinements in precision that ultimately enabled the construction of monuments that have stood for 4,500 years. Inside the pyramids, the geometry continues. The king's chamber in the Great Pyramid uses corbelled stone ceilings, each layer of stone slightly overhanging the one below, distributing load outward. It has survived 4,500 years of seismic activity without collapsing. The Great Pyramid is oriented to true north with an error of just 3/60 ths of a degree. In 2500 BC, without magnetic compasses, using only star alignments. The Egyptians identified the pole point of the northern sky and used it to orient their most important monument with near-perfect precision. From a knotted rope stretched across Nile floodplain, to the precisely angled pyramid climbing 146 meters into the Egyptian sky, to the Rhind papyrus encoding the mathematics for future generations, to Roman surveyors applying the same principles across Europe, to the CAD software designing today's skyscrapers. Egyptian geometry never stopped working. I am Takku. The Great Pyramid has stood for 4,500 years and is still the most precisely oriented large structure on Earth. It was built with mathematics so sound that time itself has not found a flaw. Subscribe to Wisdom of Takku, because the greatest proof of good mathematics is that it lasts.